Okay, welcome to practice problem number 1 for homework number 11. We're going to start by restating the problem. Okay, my pen's been freaking out again, so I'm sorry if it does dumb stuff. It's driving me nuts. Okay, so we've got this plate that looks like a plate, and it is 2 meters wide. And then we've got another plate that is arranged to the bottom and right, and it's also 2 meters wide. And these are separated by a distance of 1 meter. And we have been asked to find the view factor between surface 1 and 2, where this is surface 1 and this is surface 2. Okay, and the approach we're going to use is we're going to use view factor algebra, and we're going to use the view factor table in the book. Okay, now let's actually do it. So here's the analysis part of our problem. But before we do this, let's look at this geometry, right? So you go to the tables and you're looking for something to match these two plates that are arranged like this. But there's a problem, right? Their centers are not aligned vertically. They're offset from each other. And the closest thing you can find in the table is one that looks like this. For two plates that are aligned vertically and have a width of 1 and a width of 2 and are separated by a distance L. And you say, okay, well, these plates almost work. They are parallel just like here, but the centers here have to be aligned, where here the centers are not. So what we're going to have to do is change our setup here a little bit. Not change it, but think about it in a different way. So I'm going to draw it again, but I'm going to add now some fake surfaces, some pseudo surfaces we'll call them, that aren't real, but that we're going to use to find the view factor we care about. So again, here's surface 1, here's surface 2. Now I'm going to add another surface coming out like this. That's surface 3. And I'm going to add one more out here. That is surface 4. And then I'm going to say that all of these are the same width, 2 meters. And this one is also 2 meters. And they're all 1 meter away from that top plate. Okay, and the reason I'm doing that is because now look, right? We can find the view factor from surface 1 to surface 2, 3, and 4 combined into one complete surface. See how those look exactly the same? And we can find the view factor from surface 1 to surface 3. Because remember, they can be any width we want as long as their centers are aligned. And here our centers are aligned for both 1 to 3 and 1, 2, 2, 3, 4. So let's just go into that a little bit more and see why that matters. Okay, so I'm going to just draw that surface again up here for us to use to visualize. So here's surface 1. Here's surface 2. Here's surface 3. Here's surface 4. That's surface 4. Okay, so remember, we can find the view factor from surface 1 to surface 3. Right? So that's right here. And we can do that using the first entry in table 13.1. So to show you what that would look like, f from 1 to 3. So I'm getting this equation straight out of the first entry in table 13.1 is going to be equal to big W1 plus big W2 squared plus 4 all raised to the 1/2 minus big W2 minus big W1 squared plus 4 all raised to the 1/2 divided by 2. Oh my gosh. 2 times big W1. Okay, so again, this equation right here, I just got straight out of the book, entry number 1 in table 13.1, and that's I'm using to describe the view factor between 1 to 3. So all of the energy that will hit surface 3 that left surface 1, the fraction of it, right? So remember, just as a review, the view factor here would be heat that hits 3 from 1 over all of the heat from 1. And this equation right here is going to tell us that. And there's some important things we need to know, which is big W1 is just equal to little w1 over L, where L is the distance between the plates, and little w1 is, again, the width of plate 1. And then you guessed it, big W2 is just little w2 over L. Okay, so you see we can find the view factor from 1 to 3 using this equation right here after we calculate big W1 and big W2. Okay, so if you do that, F13, you get 0.618. All right, so that means that 61.8% of the energy that leaves surface 1, so 61.8% of the energy leaving here is going to hit surface 3. But that's not what we're looking for. We're looking for F from 1 to 2. So how are we going to find that? All right, so we got to do a little bit of math here. So I'm going to draw our surfaces again. Here's 1, 4, 3, and 2. Okay, so we're looking for F12. Oh my gosh. Okay, so we're looking for F12. And there's a few things we can say, right? Like, for example, F from 1 to the combined surface 2, 3, 4. So F from 1 to this whole surface has to be equal to F, oh gosh, that was my mistake, sorry. Let's go back up here so we can see. F from 1 to 4 plus, this is driving me nuts, F from 1 to 3 plus F from 1 to 2. All right, that's the partition rule. So we've broken this big surface, 2, 3, 4, into 3 different sections. And we're saying that the view factor from 1 to the overall surface has to be equal to the view factor from 1 to each individual surface, all of them added together. Okay, so that's great, but now we're going to do another thing with our view factor algebra. We're going to recognize there is symmetry here, which means the view factor from 1 to 2 is the same as the view factor from 1 to 4. If you were to flip this thing around, like mirror it, then 2 and 4 would look the same, and so the view factors are the same. So we can say F12 equals F14, okay, which is nice because you see we have F14 right here and F12 right there. So we're just going to plug F12 into where we have F14 right now. Okay, and then also F13 we just found, right? So we can now write F1 to 2, 3, 4 is equal to 2 times F12. Remember, we said we used this to put F12 in there, and we've added them together, plus F13. So we know F13. We're looking for F12, so we just need to find F1 to 2, 3, 4. Well, coming back up here to this equation, so you see we used this equation right here, which we got from the book, which applied to parallel plates with their centers aligned, right? Well, F1 to 2, 3, 4 also works, right? Because their centers are aligned and they have different widths. So now this total width here would be the width of surface 2, 3, 4, like a combined surface. And we can use this same equation to find the view factor from 1 to F2, 3, 4. And so here we have the view factor from F1 to 3 written, so we're just going to write F from 1 to 2, 3, 4. And again, we use the same equation, but now we had to calculate. So big W1 stayed the same, but now this W2 would be W234, which would be the width of 234 divided by L. And that now we're going to plug in here where we have W2 written down and get a new view factor, the view factor we need, which is F from 1 to 2, 3, 4. And I did that for you, and it's 0.944. Goodness. Let's write that again, just so we're clear. 0.944. So 94% of the energy leaving surface 1 is going to hit surface 2, 3, and 4. Okay, so that's great. We have now found this value. So we can solve for what F12 is because we know F13. We found that right here using the table, and we know F1, 2, 3, 4. So we know this and this. We just solve for this. And when we do that, we get 0.163. Okay, so 16% of the energy leaving surface 1 is going to hit surface 2. Okay, so as a discussion, I'm going to say, that's not a lot. Okay, well, thank you for watching. I hope this was helpful, and I'll see you in practice problem number 2.